Hello students, welcome back to worksheet number 2. This is video of worksheet number 2, part B, getting to the back side of the worksheet as promised. And these problems are just showing some examples of how we can apply what we learned on the front side to actually solving some equations. So we've got a couple here, we got 4 here. So I'm just going to pick 2 of them, so I'll pick this one right here, number 13. And let's do some of that work up here since I got a lot of white space up here to work with. And again, just solving equations, I'm just going to start doing what I call the middle school math first, because what we're going to do is isolate that cotangent of theta alone. So I'll just end up subtracting 1 from both sides. So I'd end up having root 3 times the cotangent of theta equals -1. Divide both sides by the root of 3, so I'd have cotangent of theta equals -1 over root 3. Now some of you might get a little nervous because you see a radical on the bottom here, but I think this is going to take care of itself here, because normally we like to solve for sine, cosine, or tangent, because that's the kind of way our unit circle is designed. So that's fine, because what we're going to do is the reciprocal of cotangent is tangent, and then all I got to do is reciprocate this side. So that'd be root 3 over -1, or simply you could just say tangent of theta equals negative root 3. All right. So then this right here, now we're just solving for that theta. So we're looking at the theta equals the inverse tangent of negative root 3. Okay, so thinking about tangent, and thinking of that unit circle, we know tangent is negative in this quadrant and negative in this quadrant. And when we think of root 3, root 3 for tangent is going to be right here, and, oops, sorry, right here, my bad. I'm going to be in the negative area, and then right here. Alright, so I'm going to just erase that little piece right there, because that wasn't right. And, well, so again, the root 3 is up here, and we're asking for our answer in degrees. This angle up here is 120 degrees. This angle down here is 300 degrees. And again, you can go back and look at the unit circle here as well too. There's our 120 and there's our 300 for those pieces right there. And then our unit circle. Here's another problem. I'm just going to do this one. This is the only one like this on this page, but you'll see these come up as we review and keep practicing these problems in the future. But this one's got a square in it. It's a second degree equation. So don't get too overwhelmed with that. What you can do is just kind of treat this like you would have like an algebra 2 problem or advanced algebra problem, that this is just like 2x squared plus x minus 1 equals 0. When we solved these problems in the past, we worked on just factoring. So we knew we could break this down into 2 factors equals 0. And what you learned in advanced algebra was that X-box method. So we looked at that X-box method for solving this problem. So this might be a little review for a lot of people. The number that goes in here, is the ax squared times the c value. The number that goes down here is the b value. And then we looked at these 2 numbers, and we have to kind of guess and check here for what 2 numbers, when multiplied, give me this number, but when added, give me this number. And then we'd use these two numbers that we were guessing and checking on, they go here in our box. This number right here, was just simply our ax squared. This one was just our c. And then we looked at the GCF for the numbers that go here, here, and then here, and here on the boxes. So let's kind of play this out a little bit. So see if you don't remember. So this number up here is the ax squared times c. So I'm going to take that 2x squared times the negative 1, and that's negative 2x squared. The b value just goes down here, which is just that x value. So now we got to sort of guess here, guess and check, and we're playing a little game here. Think about what two numbers, when multiplied, give me negative 2x squared, but then when added, give me x. Well, 2x and a negative x. 2x times negative x gives me negative 2x squared, but when I add these two together, it gives me x. So then when I make in my box, I know these two numbers are going in these boxes. I know this box here would be the 2x. This box right here would just be the negative x. And then I'm going to take the first number that was in our problem, which was the 2x squared. This number right here is our last one, which is negative 1. And then we'll look at getting the GCF all four ways. So when I look this way, look to see what's the GCF, and that's just x. When I look this way, the most I can take out is just simply a 1. When I look up and down here, hey, I can take a 2 and an x out. And here, because my first one is negative, I'm going to want to take a negative out, and that's the only thing I can take out is a negative 1. So here are my factors then. So there's the x, it's the x plus 1. This one right here is 2x minus 1. It doesn't matter, you can write this grouping here first and put it over here and put this grouping there, that doesn't matter. But then now we got to remember how to solve these problems. And again, this is just saying if I've got this quantity here times this quantity here equaling 0, I know one of them must be 0, so I know that x plus 1 equals 0, or 2x minus 1 equals 0. And just got little algebra problems here now. So x equals negative 1, or if I add 1 divided by 2, x equals 1/2. But wait a minute. These weren't x's. You substitute that. These are actually, when I look at these problems, this here is really not x equals negative 1, but sine of theta equals negative 1, or sine of theta equals 1/2. So when I'm looking at these problems then, I'm looking at saying, well, where is theta equals the inverse sine of negative 1? So in other words, where is sine negative 1? So in other words, where is the y value negative 1? Well, that's just right here. And that's at 3 pi over 2, or 270 degrees. I think they wanted the answer in degrees. And that's the only place that y value is negative 1. So in this problem right here, theta equals 270 degrees. There is only one answer for this one. You'd think there might be two, because we're solving, it's an equal sign, but there is only one place where sine is negative 1. So there's one answer. And over here again, we're looking at theta equaling the inverse sine of 1/2. So we want to find out, again, because we're solving, we're going to get two answers here. We're going to look to see, well, where is sine 1/2? Well, again, remember, I know sine is positive in quadrants 1 and in quadrants 2. Well, where is sine 1/2? Well, right there, which is 150 degrees. And then also then right here, which is 30 degrees. So theta would equal 30 degrees or 150 degrees. So we got the two answers here plus that one answer there. Well, the problems below here are review from the previous worksheets, so you can give those a try. I'd also go back up and try these other problems, 13 and 14, and then again make sure you finish these other problems back here that we didn't do. Alright, so hopefully this is good. Otherwise there are some additional videos for support as well for the concept. Some Khan Academy videos that are also available in our Schoology page as well too. Otherwise, send me your questions and we'll get you through this. All right, take care now.